So Rachel did a terrific job helping us develop the basic algorithm. Now it's time for the part that's even more fun, which is translating that algorithm into code. So for that, I've asked Vaishnavi to come in and lend us her hacking expertise. So Vaishnavi, Rachel helped us come up with a really good algorithm that I'm sure is correct. Now the next question is it efficient? So what do you think?
I think there's potential to make it much faster.
Oh really? How so?
As is, I see two potential limitations. First, it might do too much work. Second, it might use too much intermediate storage.
Okay, I think I know what you mean, but can you elaborate?
Sure. Let's say there are m receipts and n possible items. If all possible pairs of items actually co-occur, then in terms of storage, the table might need up to n square entries.
Right, that makes sense. So Amazon has hundreds of millions of products in its inventory, and that number squared is tens of quadrillions.
Yeah, I read somewhere that $10 quadrillion in $1 bills would cover the entire surface of the Earth 10 times over.
That's a lot of cash. So what about the work?
The work is similar. If any item set pair exists in the data, the algorithm visits it. But later, it filters out many of these against the user's threshold.
Ah, good point. So depending on how large the threshold is, it's possible most of the rules won't be viable. So I think your main point is that we want to handle lots of data, or big N, so algorithms that scale like n squared in time or storage are really bad.
Yes, exactly. It would be better to design algorithms that scale like n log n or just n. Here's a more general way to think about our algorithm design goals.
Great, please enlighten me.
Let's say the problem has an input of some size, call it n. The output or results will also have some size, call it k. Ideally, what you really want is an algorithm whose scaling is proportional to n plus k, or maybe n plus k by log n plus k.
Ah, that makes perfect sense. So in the computer science world, we call an algorithm that scales linearly, like O of n plus k, work optimal. And goals are good.